Hi everybody. So I'm going to do a couple of videos on how to deal with inverse trig U substitution problems. The first one actually won't be a U sub, it'll just be dealing with limits of integration in inverse trig land. So we're going to begin with talking about taking the antiderivative from 0 to 1/2 dx over the square root of 1 minus x squared. Now, I've given you the formula that is actually equal to sine inverse of x, and it's going to be evaluated from 0 to 1/2. So what's going to happen is you're going to take sine inverse of 1/2 minus sine inverse of 0. Now, I have a couple of comments here. I said, where is sine inverse positive? Because you're dealing with a positive argument there. Well, that happens to be in quadrant 1. So you're going to draw your triangle in quadrant 1, and my comment will be that 1/2 is one of the recognizable 30, 60, 90 ratios. So we situate ourselves so that here is our angle, and sine is opposite over adjacent. So here's the 1, here's the 2, and we use the Pythagorean theorem to find the third side. But that's the 30, 60, 90 right triangle. That's one of our special right triangles. So what we're actually looking at is an angle of 30 degrees. Now, we'll come back to that in a minute. Sine inverse of 0 is, and I said, what is sine inverse of 0? I really should have said, where is sine inverse of 0? Well, it's a quadrantal. So let me scoot this camera down just a smidge. And we're going to be looking at the fact that we are at where cosine and sine have 1, 0. That's that ordered pair. We're on the quadrantal. That is 0 radians right there. And if we were at pi over 2 radians, it would have been cosine and sine, and we'd have had 0 and 1. So remembering your quadrantal angles is important. So sine inverse of 0 is 0 radians. All right. Now I said I'd come back to the 30 degrees. We need this in pi radian form. So the way we convert that is by setting up the ratio. 30 degrees over 180 degrees is equal to what we're trying to figure out over pi. 180 represents the pi, and then 30 degrees represents the angle that we're trying to get into radian form. Well, I'll cross multiply, and so I'll have 30 degrees pi over 180 degrees. Our units cancel, also our zeros cancel. 3 goes into 18. So we end up with our x being pi over 6. So we travel back to what we were talking about, and we say that sine inverse of 1/2 minus sine inverse of 0 is really pi over 6 minus 0, which is pi over 6. Okay. Now, I'm going to turn the page, and I'm going to mess you up a little bit here, so I'm going to have to lift this and slide it over. My apologies for doing that to you. Okay. So we're now going to look at what if we have something that's in one of the inverse trig forms, but we have, instead of a 1 there, something like a 25. All right. So the form that we're trying to get to is having a 1 in this spot, and this is our argument. Well, this is going to seem a little strange. But what we're going to do is we're going to factor out a 25. And if you think about it as distributing the 25, 25 times 1 gets you back there, and 25 times that expression gets you back to x squared. So I factor out a 25 of those, and I set it in the square root. Well, when I pull that out of the square root, I end up with 1 over 5, the integral of 1 minus. Now, I'm trying to get this to have the argument squared. So I've got to treat this as x over 5, because x over 5 squared is x squared over 25. But this is what's going to end up being the u that I use for my substitution. So I'm going to have u is equal to x over 5. du will be 1/5 dx. Now, if you'll notice, I had the 1 over 5 on the outside. I decided to bring it back in and create my du right here. And this part will be my u. So now I have the integral of 1 over the square root of 1 minus u squared, because remember u is the x over 5, du, and du was the 1/5 dx. So that is now the sine inverse of u plus c. And now I grab my u and I bring it back into the argument. Now I'm going to travel down here and I'm going to say, okay, we're going to end up doing a similar type of problem. This is one that has the radical, or the one above has the radical in it. This one is going to end up being a tangent inverse problem. So I have the 36 in this place, and this time I'm going to factor out a 36, and when I factor it out, because I don't have a radical to deal with, I can just pull it out in front. So I have 1 over 36, and again, if you distributed it back through, you'd get back over here, because 36 times 1 is 36, and 36 times x squared over 36 gets you to the x squared. All right, so I have 1 over 36, and I'm going to think about how to make this all one piece like I did up above. So I'm looking at it and going, well, 6 squared and x squared. So 6 squared, x squared, this is x over 6. I hope you see that. I'm probably not saying it well, and my apologies if I'm saying it poorly. But the idea is x squared, there's your x squared. 6 squared, there's your 36. Now this is what we let our u be. Our u will be x over 6. du will be 1 over 6 dx. And so it's not such a nice conversion there, so I just said I'm going to leave the 1 over 36 out, and I'm going to have 1 over 6 dx, and I'm going to multiply both sides by 6. So now I have 6 du equals dx. I put the 6 on the outside. I put my u in place of the x over 6. And so now these reduce to 1/6. Scroll this down a little bit. And this becomes tan inverse u, and then plus c. I bring my u back in, and I am all set. Hopefully that helps a little.